From the diamond oceans of Neptune to the water scattered on various planetary moons, let us show you some of the most incredible oceans that exist in space. The diamond oceans of Neptune and the King of Heaven. There are 8 or 9 stars in the solar system, including the Earth. In any case, the only 2 extraterrestrial stars that we can see through probes and satellites are the King of Heaven and the King of Heaven, which are gaseous stars that most people think that they could not have an ocean at all, but your assumptions are wrong. But your assumption is wrong because not only do they all have oceans, but their oceans are strictly composed of diamonds. How is this possible? It has to do with the composition of the planets themselves. Mainly in the 7 planets of the Pacific Ocean under the atmosphere are bodies of water. Inside them are veins of water, ammonia, and methane ice. On the surface, this doesn't mean much, but both planets have imposed their own effects. Not only are both planets under tremendous pressure, but they're also under pressure at temperatures between 1727 degrees Celsius and 4727 degrees Celsius, and when you mix these elements, methane breaks down into the various components of the whole, and one of them is carbon. When the carbon is under enough pressure, it creates the diamond. But that's not the case. Because of the relationship between geologic location, heat, and pressure, there are actually 2 types of diamonds that roam these oceans: hard diamonds and liquid diamonds. The diamonds formed under planetary pressure eventually melted and sank to the surface, so there was a layer of hard diamonds and a layer of liquid diamonds. Some people have even speculated that because of the heating and pressure, there are diamond fibers in the Neptune and the Cepheus, which is absolutely visually shocking. There's no doubt that some people would want to go and get these diamonds and try to make a fortune, but they would have to wait until we could actually get to those oceans. Another theory about these unique oceans is that the weight of the diamond ocean cancels out the axis of the 2 planets, so that's probably why the planet is in such a strange tilt. 9 of the magma oceans of Jovian are moving from the Diamond Ocean, and we're now moving to the hottest ocean in the solar system, but it's not a planet, it's a guardian planet, Jovian, and that's not a great deal of clarity for those of you who understand guardians, because Jupiter is the most dynamic planet in our solar system. And that's why it's so important that we have a planet that we're not in. Jupiter I is the most active satellite in our solar system, with more than 400 volcanoes on its surface. Now it would be nothing if they were not constantly erupting, but they are. The Guardian was very much disturbed by these volcanic eruptions, and then it got even bigger because there were magma flows sweeping across the Guardian, and that took us to the ocean, which is hard to believe because it didn't camp out after a while like most molten rock does. Jovian's position in relation to Jupiter and its neighboring moons keeps the molten rock in a liquid state. The position of Jovian relative to Jupiter and the neighboring moons keeps the molten rock in a liquid state, so there is indeed an ocean on top of it, which is a liquid, hot magma. Why? Because Jupiter gets so much internal and external heat that it is hot all the time, so there is no way for the magma to cool down. It's also basically a power generator for the satellite, and it produces so much electricity that a collision could cause a flash of lightning in Jupiter's atmosphere. No one would say differently about the fact that the planet Minmus is a planetary star. But because of the distance between Minoan and the Sun, you would probably think that nothing on Pluto is possible except for ice. It's so far away from the Sun that it's basically impossible for it to heat up, so its surface temperature is sometimes 24 degrees Celsius below zero. So ice is absolutely impossible to exist. But what about the ocean? This is probably due to the fact that this particular ocean is under the surface of the planet, and it is heated by a very unexpected source. Like many other planets in the solar system, beneath the surface of the lost type are buried radioactive elements, in particular, oil-40 and Earth. When they enter the radioactive decay process, they emit heat, which is powerful enough to melt the planet's ice and keep it liquid. Yes, you heard right. There could be a river ocean underneath the surface of Brighton, and that's still just a theory based on some of the things we know about Brighton. It must be very strange that it would coincide with something else known about Minmus. Maybe that's why they didn't consider Minwang as a planet. They didn't want any more nuclear planets in the solar system. 7 Kepler-62's ocean world. If you've been studying space for a long time, then you know that many people are looking for a potential planet where mankind can go and live one day. One of those planets could be Kepler-621, orbiting a red dwarf star. This planet has attracted a lot of attention because it is located in a sawbelt. That is to say, because of its position towards the Sun, there is the possibility of water and therefore life. Now there are a few things to keep in mind before you pack your bags for Kaplan. One of the biggest reasons is that Kepler is too far away for us to get to at the moment. But the other reason is that this could really be a world of the global ocean. How is this different from the Earth? Because the Earth and land masses have vast oceans. But early studies of Kepler 621 suggest that this planet is a true water world with no apparent land masses. Of course, this is just speculation, because we haven't had a chance to look at it very closely yet. But many people believe this to be the case. And if that's the case, it's really a great thing to see. However, it is not yet. However, it's not a good place to live. 6 Kepler Alphae's life ocean, what is that? Another Kepler planet? Why is that? Kepler Alphae is another planet, except for the last one, which many people think may be a special planet. They think it's a planet that we might actually live on. Or more accurately, there are lives out there right now. And yes, many scientists have hypothesized that life already exists in the oceans of this planet. If you remember, the planning theory is that all life begins in the water and then grows on land. In that sense, it would mean that this planet is a place where we humans could go down to live someday. It's 600 light years away from us, which begs the question, because a lot of the speculation and theories are based on a few pictures that we've seen since we've been able to locate this planet a long time ago. But there's still a reason to hope, as some have pointed out, that this is a place where we can live. But we have reason to hope, as some have pointed out. Natalie Battaglia, Deputy Director of Science at Kepler, says the possibility of life in such an ocean is not ruled out. 5 Earth 2's underground life ocean, we haven't shown you a potentially life-giving ocean yet, but it's a distortion of the formula because it's a very potentially life-giving ocean, but it's underground. It's also not a planet, it's a guard star of Saturn, which obviously changes the game in different ways. So how do we know that there is life and water underneath the guard star as you might expect? Simple, because Tuviel is known to have ice and fire fans that keep spraying water vapor into the air, some of which escapes into space. The Cassini space probe and other equipment studied these bodies and found that they contain nanites. This is possible to find in the ocean. In addition, the Cassini space probe discovered that they contain neuritis. It's cryptic signal, and since there are rocks in the oceans, this means that if matter is mixed in some way, then there are compounds that are suitable for life, which means that to find other life in the universe, we may only have to go to one of the guardian stars of the star vomit, the 4 ancient gods, and the unlikely ocean. The next one is a bit strange in itself, because it's not a planet or a guardian. It's actually a rocky object filled with the solar system's belt of many planets. In fact, it is the largest object in the belt, accounting for a large part of its weight. By definition, it's a dwarf star, so it's impossible for something like an ocean to exist in it. But it has one. This was discovered by the Lemonheigh probe. At that time, he spotted a bright light on the surface of Mars. It was said to be an ice volcano. As we mentioned earlier, these volcanoes shoot water vapor into the air from below, so we don't know why this dwarf planet's surface was so bright. Why there is an ocean under the surface of this dwarf planet is not it. 3 Jupiter's record-breaking ocean. Jupiter is another planet that we define as a gas giant. It is the largest planet in the solar system. But as scientists have learned, although its outer layer is gas, its surface is mostly liquid. Its surface exceeds 78% apparently liquid ocean, which makes it the largest known ocean in the solar system. If you are curious, this particular ocean has a depth of more than 53 kilometers. It is a very large ocean. It is shocking that such a huge ocean exists on Jupiter. It would require enormous pressure and chemical forces. So there are only a few theories to explain how its existence on Jupiter could have occurred. The lobster ocean. It would be strange to clarify that this is not a world full of lobsters. Instead, it is a theoretical ocean that some people believe exists on a tidally locked planet. Some believe it exists on tidally locked planets. Based on this theory, scientists built models based on the idea that these planets could retain an ocean of water on their surfaces, regardless of their temperature. They focused on known tidally locked planets and made a model to see what they would look like. The answer was that they would be ellipsoidal oceans with claw-like extensions, hence the name lobster oceans. So far, none of the oceans have been proven to exist. But this is more about the limitations of our current technology than it is about proving that this will not happen. One semi-tourist sitting on a second planet must be able to play in the marine world. Earlier we showed you an event that was thought to be a real ocean planet. Well, in a way it's the opposite. There's a place in the Quasimarine Binomial region called Quasimarine Binomial BB. This planet isn't in the star band around which it's orbiting. This planet is not in the stellar band around which it is circling. So the heat generated by its proximity makes it a place where molten rock and magma are almost ubiquitous. Its surface temperature is said to be 124 degrees Celsius, 3 times that of Venus, which is very hot due to the greenhouse effect. Now, since we haven't seen this planet in person, there is some speculation as to whether this is real or not. But if it is true, it would be another place where mankind would never want to go. What do you think about the various oceans that do exist in space? Are you surprised by the depth and composition of these oceans? Tell me about it in the comments below. Thank you for watching. This is a small world of information, so stay tuned for more.